going to solve find center of star graph. So here is an undirected star graph consisting of n nodes labeled from 1 to n. Mind that it's not from 0 to n. A star graph is a graph where there's a center node and exactly n minus 1 edges that connect to the center of the node, the center node. So let's see an example. So they are giving a 2D integer array edges where each element of that array represents the edge between the two vertices, two nodes, and that means there's an edge between u and v. So let's see this example. Here it's a star graph with two as the center. So they gave a edges array. Like when we observe this array, we can see that in every element there's a center for sure. Here there's two. So we just have to simply return 2. And in this also, we can see that every element of this array has one number in common, that is the center. So we can solve this using hash map, where like we'll take a hash map and then uh, we'll scan through each and every element of the edges array, and we'll increment the count of each number node, and finally we'll check which node has the maximum count and return it, simply return it. So let's start coding. Let's initialize the hash map. Then for L, so there's a list, it's a list of lists, right? So for L in edges, and for I in L, if we'll check if the hash map, like if the element is already there in hash map. If it is not there, then we have to take the count as 1, right? So if I not in hash map, we'll write hash map of I is equals to 1. Else hash map of I plus equals to 1. So by now we have gotten all the counts of all the nodes. Now to check, to find the maximum count node, the node with the maximum count, we can do it by separating, taking the key elements, like hash map has a key value, right? It's a key value pair. So we'll take a list of keys and list of values, and then we'll simply return. I'll just show you. List of hash map dot values. This will give all the values, I mean the counts. Then k is equals to list of hash map dot keys. This will give all the distinct nodes. Now to return, we'll return k of v dot index, the index of the element in the v list with maximum v. So with the maximum of these values, I mean the maximum count, the index of that is extracted, and that index is same as the index in the k list. So we'll simply return it in this way. Let's run this. It's running properly. Now submitting it. There is another simple way in which we can solve this problem uh, using using the indices of the list. As we can observe here, this it's a list of lists. So we can play with indices here. Let's just the intuition of this solution is we know that for sure in every list, small list, there is an answer for sure. So we're just going to check if we're going to take the first element and check if it's there in the next list. If it is there, then it is the answer for sure. If it is not there, then the next element of the list is the answer. Because there's for sure a common element uh, in all the lists, which is the answer. So let's start coding for that. I'm taking t as edges of 0, comma 0, which is the first element of the first list. Now we are returning t if t is in edges of 1. We're checking in the other small list. If it is there, then we are returning it. Else, we are returning edges of 0, comma 1. That is the other element in the first list. Let's submit this. It's running fine. Thank you for watching.